Special right triangles, you learn to find missing measures in a 30-60 and a 45-45 right triangles. Let's consider this activity. Construct and cut out a square. Let me read the directions and then we'll demonstrate it. Fold the square along the diagonal to form an isosceles right triangle. Measure each leg and each angle of the triangle. Use the Pythagorean theorem to determine the length of the hypotenuse. Use a calculator to divide the length of the hypotenuse by 2. And then we are asked to describe the method for finding the length of the hypotenuse of a right isosceles triangle. Okay? And let's see how this works using what we know. Okay? Let's first make our right triangle, our square. And our square will look something like this. Okay? And what do we know about our square? Our square has all sides congruent. So if this is our square, again, a square also has 4 right angles. Okay? And the total measure of all the angles in a square, okay, is 360 degrees. Therefore, one triangle is 180 degrees. So to be able to find the measure, okay, if this is our right isosceles triangle, since this is 90 degrees, okay, and this is 90 degrees, half of it is 45 degrees. So our isosceles triangle, it has measures of 90 degrees, 45, and 45. Okay? Going back to our square, if our square has a side of 4 inches, okay, to be able to find the measure of our hypotenuse, which is c in this case, let's use the Pythagorean theorem, which is c squared equals a squared plus b squared. And in a square, a is always equal to b because all the sides are congruent. So in this case, if a is equal to 4, substitute the value. C squared is equal to 4 squared plus 4 squared, or c squared is equal to 16 plus 16. C squared is equal to 32. Okay? Erase that, 32, make it prettier. And to be able to solve for c, get the square root of both sides, so c equals radical 32. One of the directions on the activity says that after getting the value of c, we need to divide this by 32. So we get the value of c, which is radical 32, and we want to divide this by radical 2. Okay? So using our calculator, using my calculator, if I get radical 32, nope, not that one. If I get radical 32 and I divide it by radical 2, what comes out? It's equal to 4. What do you notice? Okay? If this is equal to 4, it is the same as our side of the square. So, how do we find c if we know the side of the square? Okay, logically, all we need to do is multiply it by radical 2. Okay, which brings us to letter A. Describe the method for finding the length of the hypotenuse of a right isosceles triangle. If you know the length of its sides, then all we need to do is to be able to find the length of our hypotenuse. Okay, we need to multiply radical 2 times the length of a leg. Okay? Let's consider the next activity. In the next activity, you're asked to construct an equilateral triangle. Remember what an equilateral triangle is. It's a triangle where all sides are congruent. We want to cut it out, fold the triangle to form a right triangle. Measure each side of each angle of the right triangle. Repeat the steps above for several other equilateral triangles. Okay? So, what do we know? Let's answer the questions B and C later on. We're asked to create a right triangle. An equilateral triangle. Okay? And we're asked to make a right triangle out of our equilateral triangle. What do we know about our triangle? Okay, we know that a triangle has a total measure of 180 degrees. We also know that since it's an equilateral triangle, all the angles are congruent. That means all we need to do to be able to find the measure of each angle is to divide 180 by 3. If you divide 180 by 3, we come up with 60 degrees. So this is 60 degrees, this is 60 degrees, and this is 60 degrees. Okay, since that is 60 degrees, okay, right here, sorry. So this is our equilateral triangle going back there. And the total measure of all the angles is 180 degrees. Again, since it's an equilateral triangle, all angles are congruent. So we simply divide 180 degrees by 3. That becomes 60 degrees. Okay, and since this angle is 60 degrees, 1/2 of it is 30 degrees. So they're both 30 degrees. So our angle now, this right triangle, will have, okay, a 30 and a 60 degree angle. Of course, plus the right angle right there, which is 90 degrees. Okay? Okay, let's put some measures on our on our equilateral triangle. Let's say our equilateral triangle has, let's do 6 inches on all sides. If our equilateral triangle has 6 inches on all sides, okay, this one now will measure 3 inches. Okay. Now, what do you notice about the measure, okay, of the base of our right triangle? Okay, if this is now our right 30, 60 right triangle, remember this is 30 degrees, and this is 60 degrees. Okay, let's answer this question right here before we continue. Question is, what is the relationship between the shortest side of and the angle having the smallest measure? Since 30 degrees has the smallest measure in our right triangle, okay, what is the relationship of the shortest side? This is the shortest side right there. Okay, the relationship is that, sorry, did not see that. If this is our 30, 60 right triangle again, and this is your 30 degrees right here, and this is 60 degrees. Okay, the relationship of the 30 degrees and the shortest side is that, this one right here, is that they are, okay, opposite each other. Okay, so this particular angle right here, if I put it here, this is 30 degrees. Okay, and the relationship there is that they are opposite each other. Okay, so they're opposite each other. Now the question is, what is the relationship between the length of the hypotenuse and the length of the shortest side? This is the length of our hypotenuse right here. Let me bring my triangle back. Okay, let me clear that up. If this is my right triangle, again, and this is 30 degrees, and this is 60 degrees, okay, and this is, what measure did I put? 6 inches. 6 inches, and this is 3 inches. What is the relationship of the shortest side and the longest side? Okay, so if this is C and that is A, so the relationship is that A is equal to 1/2 C, or C is equal to 2 times A. That is now the relationship between the length of the hypotenuse and the length of the shortest side. Okay, it's twice as long. Okay, which brings us to some rules of our special right triangles. The first activity that we finished is a 45-45 degree right triangle. The triangle in the second activity is a 30-60 right triangle. The relationships we discovered above are true for any 45-45 degree and 30-60 right triangle. Okay, which brings us to this point. In a 45-45 degree right triangle, you can find the length of the hypotenuse by multiplying the leg by radical 2. And this is the formula. Hypotenuse is equal to A times radical 2 in a 45 degree right triangle. Okay? Let's consider this example. We want to find the length of AC in triangle ABC. This is the length of, we're trying to find this length right here. Okay? We're trying to find that length. Triangle ABC. We know that it's a 45 degree right triangle. Okay? And this is our hypotenuse. Okay? This is our hype. Okay, there you go. Oops. Hypotenuse. Okay? So if that's our hypotenuse, let me just write that. Hype. Okay? That's our hypotenuse right there, because that is the longest side of our right isosceles triangle. What does that mean? If we follow the formula C equals A radical 2, and we know that A is 5, substitute the value to A, replace it with 5, we now have 7.07107812, or the length is about 7.1 centimeters. And that's how we find the value of the hypotenuse if it is a 45 degree right triangle. Let's consider the second example. In a 30-60 degree right triangle, the length of the side opposite the 30 degree angle is 1/2 the length of the hypotenuse. Simply put, A is equal to 1/2 C. The length of A, which is this one, is equal to 1/2 the length of the hypotenuse. Simple enough. And if we consider that those values in that right triangle, we find the length of A to be 6, because 1/2 of 12 is 6, so the length of A is 6 inches. Okay? Another formula, the third formula for special right triangles, is this. In a 30-60 right triangle, you can also find the length of the side opposite the 60-degree angle by multiplying the length of the other leg by radical 3. Remember, in the last example, we found the length of A by getting half of the hypotenuse. In here, and we know for a fact in the last example that A is opposite the 30-degree angle. Now, how do we find the length, okay, of the side opposite the 60-degree angle? We do this by multiplying the length of the other leg by radical 3. Or we follow this formula to be able to find B, which is the opposite of our 60-degree angle. B is equal to A radical 3. Okay? So going back, let's look at this example. Large doors like those in barns and airplane hangars are often reinforced with diagonal brace to prevent warping. Barn doors designed so that the brace forms a 30-degree angle as shown. So if you look at this example, this is our 30-degree angle right here. If that's our 30-degree angle, naturally this becomes our 60-degree angle right here. So this is our 60-degree angle, which means that the opposite of our 60-degree angle, okay, is B. So this side is B, okay, and the opposite of our 30-degree angle is A. So this side is A. Okay? If the width of the door is 7 feet, how high is the door? So what is given? What is given is A. A is equal to 7 feet. So we simply follow the formula. Okay? B equals 7 feet. Okay? Sorry, A equals 7 feet. We substitute the value. B equals 7 times radical 3. And now we have B equals 12.1. Okay? The door is about 12 feet high. And that's how you use the special right triangles to find values of the legs and the hypotenuse. Okay? But remember, this only works for 30-60 right triangles and 45 degree right triangles. Okay? Lessons done. I hope you've taken down notes, write a summary, and at the bottom of that summary, on a different paragraph, write a question you might want to ask in class. Okay? Thank you.